All right, so yesterday we were graphing some equations. Today we get to write them on our own, and it's going to be predominantly through word problems. So there's some variables you're going to want to know. First of all, instead of using x and y, okay, so you know like in an equation y equals mx plus b, the m and b would end up being, I don't know, whatever numbers you want them to be, but x and y were always there. They never changed. That's going to be the same for today. You're always going to have x and y, except instead of using x, we're going to use t. Right there. Okay? So as far as t is concerned, I want you to think x. All right, so then y is going to be the final amount. Maybe it's money, bacteria growth, population growth, whatever it is. A is going to be the initial amount, however much you start with, and money-wise, bacteria-wise, whatever. And then r is going to be the rate of change. This is key, expressed as a decimal. Okay? They're going to give you that rate as a percent, so we're going to have to convert that every time. So, number one, a college's tuition has risen 5% each year since the year 2000. In the year 2000, that tuition was $10,850. Write an equation, then predict the cost. So, the first directions say write an equation. So, again, if my final equation is always going to have x and y, or in this case t and y, really all I have to fill in are a and r. A is the initial amount. Well, how much did we start with? It tells you right here. In 2000, we had $10,850. What's also key is that they're kind of saying that 2000, the year 2000, is our baseline year. So, okay, y equals 10,850. And then it's always just parentheses 1 plus, and then my rate is 5%. Again, you need to convert that to a decimal. So move the decimal point over 2 places. 0.05. I do want you to go ahead and simplify this. In this case, actually for today, basically all day, the only thing you're going to be able to do is combine inside the parentheses. Every year I have people who go ahead and try and multiply here. And you can't do that because of this nasty little t right there. If you're following order of operations, GEMS, groupings, we did that, and then exponents is next. You can't do multiplication until you've done the exponents. So that's actually the equation. That's my answer for part 1. Part 2 says, predict the cost of tuition for this college in 2015. That's the year. That's what you plug in for T, except one tiny catch. Remember up here where it said since 2000? T is the number of years that have passed. So how many years have passed if I'm asking about the year 2015? 15. So that's what you plug in for T. So in my calculator, oops. There we go. In my calculator, what I'm going to do is plug in the exponent first. So I have 1.05 raised to the 15th power, and I get 2.0789 yada yada yada. I'm just going to, without erasing that answer from the calculator, just hit the times multiplication button. And then multiply that by the original amount, 10,850. And that amount is a pretty large number, really. $22,556.37. Since it's money, I'm rounding to the nearest decimal point, or to the nearest penny. And that's all you do, folks. They are going to also give us, we're going to skip that one for now, exponential decay. That one was growth, meaning something was growing. Decay means it's getting smaller. You'll notice there's only one difference in the formulas, and it's this minus sign. So the example otherwise is going to work the exact same. The initial amount of population this time Okay, 1 minus the rate. I need to convert that to a decimal. So 0.003 to the t power. And then again, the only thing that you can simplify is the parentheses. So that's going to be 0.997. This right here is your formula. It is ready to be, have numbers plugged in for time. Predict the population in 2010. How many years have passed since the year 2000? 10? Great. Plug in 10 for t. And I tell you what, I already have that plugged in, and the answer is 86,000. I rounded to the nearest whole person. 23 people. Hey, double check. It says that the population has been decreasing. Did my number from starting to end get smaller? Okay, just a quick double check to make sure I did it right. So up above is an example I really wanted to do. One thing we love to see grow is the dollar signs in our bank accounts. Am I right? There's this thing called interest and compound interest, and I'm going to explain that in class more, I think. But basically, here's the formula you need to know. Watch out for N, because N is the number of compounding periods per year. So, determine the amount in investment. Again, you're just plugging information in. P is the principal amount, so how much money did you start with? And the rate, again, is going to have to be a decimal. So I convert that, divided by number of compounding periods, N. It says it is compounded monthly. So how many months are in a year? 12. Okay, and then you're going to take that 12 times the number of t is years, so times 22. Here's my suggestion to you when you're plugging these in. Take the 12 times the 22, your exponent, simplify that. I get 264. Now, go ahead and I'm going to be plugging in the parentheses into my calculator. So I'm typing in 1 plus 0.035 divided by 12. And then I'm going to hit the equal sign. I get a big ugly decimal. It's like 1.00. Oops, let me get off the highlighter here. 1.002916667 or something. From there, without clearing my calculator, like my calculator still says 1.002916, what I'm going to do is hit the caret key. That's that little key that kind of looks like an upward arrow. And then I'm going to type in that exponent that I found earlier, 264. And then I'm going to hit enter. And now, where that puts me is 300 times 2.157, yada, yada, yada. Without clearing my calculator, I'm just going to hit times 300. And I get $647.20. Slap a label on that, and we're good to go. Okay, so as you can see, you don't really gain a lot unless you put a lot of money in. That's like not even $350 over 22 years, so youch.